For this example, let's talk about figuring out the mean and the standard deviation of the three different lists that are shown on the screen. So first off, let's take a look at list number 1, figure out the mean and the sample standard deviation. So the mean will be equal to 1 plus 4 plus 6 plus 7 plus 8 plus 10 all over 6. Okay, so just do the arithmetic. I've got a calculator here next to me. So 1 plus 4 plus 6 plus 7 plus 8 plus 10. Add them up, I get 36. And divide by 6, of course, I get 6. So I get an average of 6. Next step is to figure out the sample standard deviation. So the sample standard deviation is obtained as follows. First off, we find all the deviations from average. So 1 minus 6 is negative 5. 4 minus 6 is negative 2. 6 minus 6 is 0. 7 minus 6 is 1. 8 minus 6 is 2. And 10 minus 6 is 4. So taking all of these 6 numbers and then subtracting the average 6 from all of them. Okay, the next thing I do is square all of them. So negative 5 squared, negative 2 squared, 0 squared, 1 squared, 2 squared, and 4 squared. And then lastly, I average them, add them up, and then average, except when I take the average, I will be dividing not by 6, but by 5, n minus 1. And then finally take the square root of what I get. So that is my formula for the standard deviation. This is a measure of how spread out the numbers are. So doing the arithmetic, 25 plus 4 plus 1 plus 4 plus 16 is 50. Divided by 5 is 10. So the answer works out to be square root of 10, about 3.16. So the mean gives me a way of measuring the central tendency. This gives me a way of measuring how spread out the numbers are. Okay, so let me record that up here, that for this one, the mean worked out to be 6, and the standard deviation worked out to be square root of 10. Okay, let's now do part 2. So for part 2, let me switch colors. The mean works out to be 5 plus 8 plus 10 plus 11 plus 12 plus 14 all divided by 6. And so doing the arithmetic, 5 plus 8 plus 10 plus 11 plus 12 plus 14 all divided by 6, I get an average of 10. So the sample standard deviation is obtained by, we'll subtract 10 from all of these, so 5 minus 10 is negative 5. 8 minus 10 is negative 2. 10 minus 10 is 0. 11 minus 10 is 1. 12 minus 10 is 2. 14 minus 10 is 4. So once again, I square all these, add them up, divide by 5, and then take the square root of what I get. So plus 1 squared, plus 2 squared, plus 4 squared. Add them up, divide by 5, and then take the square root of what I get. Now if you notice, those are the exact same numbers that we had before, and so we'll get the exact same answers what we had before, 10. So for this one, x bar is equal to 10, while the sample standard deviation remains the same thing as square root of 10. Okay, now why did this happen? This happened because list number 2 is the same as list number 1, except that I've added 4 to all the numbers. 1 plus 4 is 5, 4 plus 4 is 8, 6 plus 4 is 10, 7 plus 4 is 11, 8 plus 4 is 12, 10 plus 4 is 14. So I've added 4, so it makes sense that the mean was increased from 6 to 6 plus 4, which makes 10. But by adding 4, the numbers don't become any more spread out. The numbers kind of get shifted, all the numbers get shifted over to the right by 4, but they don't become any more spread out relative to each other. And so the standard deviation stays the same at square root of 10. Okay, lastly, let's take a look at the third data set. Let me do this one in orange. So x bar this time will be equal to the average of these 6 numbers, 3 plus 12 plus 18 plus 21 plus 24 plus 30 all over 6. And so doing the arithmetic, we get 3 plus 12 plus 18 plus 21 plus 24 plus 30, all divided by 6, and I get a mean of 18. Now this also makes sense because list number 3 is triple the numbers in list number 1. 1 times 3 is 3, 4 times 3 is 12, 6 times 3 is 18, and so on. So it stands to reason that the average gets multiplied by 3 also. For the sample standard deviation, we take all the differences again, so minus 15. 12 minus 18 is minus 6. 18 minus 18 is 0. 21 minus 18 is 3. 24 minus 18 is 6. 30 minus 18 is 12. Okay, so I need to square all these numbers. Add them up. And divide by 5. And then take the square root of what we get. So we get 225 plus 36 plus 0 plus 9 plus 36 plus 144 divided by 5 works out to be the square root of 90. And I can pull 9 from out of the square root, and that's equal to 3 square root of 10. So S is equal to 3 times the square root of 10 for this third data set. Okay, now that makes sense because by multiplying the numbers by 3, they become 3 times as spread out, and so the standard deviation increases by a factor of 3. Said another way, that all of the deviations that I see here are 3 times as large as the ones I had for set number 1. Then by squaring and then eventually taking the square root, I get those squaring the square root kind of cancel themselves out, leaving me again with a factor of 3 increase.